Good afternoon, class. We are looking at Module 3, practice test that covers chapters 6 and 7, rational expressions and equations, roots, radicals, and complex numbers. All right, the first question, find all values for which the function is 0. Part A is 0, part B is undefined. A rational expression, a fractional expression can be 0 under the following condition. Only the numerator is 0. So you set x plus 1 equal to 0, and x becomes negative 1. A fractional expression, a rational expression is undefined when the denominator is 0. So x squared minus 49 equal to 0. You find the answers as positive, negative 7. Add. All you have to do, take a common denominator. Notice x minus 5 and 5 minus x are opposites, therefore the common denominator is just one of them. If you choose the first one to be your common denominator of x minus 5, then the second fraction can be changed to negative 1 over x minus 5. I hope you realize what we are doing. We are multiplying the bottom by negative and the top by negative. They cancel each other. We end up with 0. Part B, first we need to find the LCD. So we look at numbers 4 and 6. The LCD is 12, x squared, x to the power of 6. We choose x with the exponent 6. Y to the power of 5, y, we choose y to the power of 5. Now, the first thing I wanted to show was the LCD, the least common denominator. So now this one, what do you need to multiply it by? In other words, divide this one by this to get to the LCD. So 12x to the power of 6, y to the power of 5. If we divide it by 4x squared, y to the power of 5, we notice we need 3x to the power of 4. So you can actually do that. Which means we need to raise the first fraction by 3x to the power of 4 over 3x to the power of 4. We divide that by the second denominator, and that is division by 6, x to the power of 6, y. So all we need is 2y to the power of 4. So the first one we raise by 3x to the power of 4 over 3x to the power of 4. The second one by 2y to the power of 4. The product of these two, the product of these two, and we are done. Simplify, that means factoring. So if you look at the first one, the top is fine, the bottom is factored into x plus 6x minus 6. X plus 6 is in common, you can cancel them out, the numerator becomes 1. We are going to factor each and every piece. So starting with this, the top has to be factored, the bottom has to be factored. Division will change to multiplication, has to be factored. This one remains unchanged. So let's take a look at the first one. 5 is a prime number, so we can go with 1 and 5. We want 4 here, so either 2 and 2 or 1 and 4. This is a trial and error that will do the job. With 2 and 2, we get the middle term of 12x. How? 2 times x plus 2 times 5x, they add up to 12x. Over here, 2 is a prime number, so 1 and 2. 3 is a prime number, 1 and 3. Basically, you have to figure out where to put them. Remember, the middle term here is 2x. Here is 3x, they add up to 5x. Now this one, the top goes to the bottom comes up. So the bottom is up. So if you look at the bottom, 2 is a prime number, so 1 and 2. And all you have to do, deal with number 12, change it into 2 pieces, 1 times 12, 2 times 6, 3 times 4, and it's a trial and error. We need to come up with 11x. So 2 times 4, this is 8x, 3 times x, 3x, they add up to 11x. So this piece is the same as this piece. We do the same thing for the top. It's just a matter of factoring. Again, 3 is a prime number, 2 is a prime number, and the middle term must be 7x. Look at this one. The product is 6x. The product is x. We do the same for the last one. 3 again is a prime number. 1 is simply 1 times 1. So it can't get any easier than that. The bottom 5 is a prime number. X and 5. You cut 8 into 2 pieces, either 1 and or 2 and 4. Remember, you want the middle term. Look at this one. 20x, 2x, they add up to 20x. Now, basically, you start crossing things out. I'm going to do one of them for you. So I see x plus 2, I see x plus 2. If you keep on going with the rest of them, nothing is left. You end up with 1 because everything cancels out. Number 5, we need to factor. The top is very straightforward, r minus 3, r plus 3, because it's in the form of a squared minus b squared. This is in the form of a cubed minus b cubed. So I'm reminding you that a cubed minus b cubed can be factored into a minus b, a squared plus ab plus b squared. So this becomes r minus 3. Remember, 27 is 3 cubed. Then r squared plus 3r plus 3 squared, which is 9. Division, you flip it over and you make it a multiplication. So this has to flip over. The bottom comes up, and top, we can factor it into r plus 3 quantity squared. R plus 3 cancels out the exponent here. R squared plus 3r plus 9. This one cancels out this one. This one cancels out this one. So the numerator has nothing. Thing has been changed to 1. So in essence, you have 1 times 1 times 1. And the denominator has simply r plus 3, which is the final answer. We are going to add, again, we need to come up with LCD. So in part A, we need to factor the first denominator. This one will be factored into x minus 4, x minus 6. We can use this as a common denominator. Notice this one has 6 minus x. So we can use this one. Remember, when they are opposites, one of them is good enough. So if we use this one, the first one remains unchanged. This one, if you can rewrite it if you will. As -3 over x minus 6. This has to be raised by a factor of x minus 4 over x minus 4. So we have a huge fraction bar. The denominator is x minus 4, x minus 6. The numerator is x for the first one. This one is -3 times x minus 4. This is plus 1 times the whole thing. So all we have to do, simplify the numerator. So we are going to distribute this one. And we are going to write this as x squared minus 10x plus 24. We already know that. But the denominator, we're going to keep it as is. So x minus 3x plus 12. And as I mentioned, this one is simply x squared minus 10x plus 24. We combine like terms. We end up with the following, because we can combine x minus 3x minus 2x. Also, we can combine 12 and 24. So that's how you do that. The numerator can be factored into x minus 6 quantity squared, and x minus 6 can be dropped. Here's your final answer. We do the same thing with part B. We need to factor the denominator for the first fraction, which is a minus 2a plus 2. Therefore, the common denominator is a minus 2a plus 2. So the first fraction doesn't change. The second one becomes 1 times a plus 2, and the last one becomes a times a minus 2 in the numerator. So notice the first fraction doesn't change. This one plus 1 times whatever is missing, a minus 2 is there. So what is missing? A plus 2. And this one, a times a plus 2 is there. What is missing? A minus 2. So all you have to do, distribute. So you keep this intact. This is 1 times a plus 2, simply a plus 2. This is plus a squared minus 2a. So we combine like terms. A plus a minus 2a, they add up to 0. -2, +2 also add up to 0. So the numerator is simply a squared. All right. We want to simplify a complex fraction. How do you do that? You multiply by LCD. Notice there are 1, 2, 3, 4 fractions, and x times y is the LCD for all 4. We're going to multiply the top and the bottom by xy. This is the fastest way to do that. So term by term, multiply by xy. For example, if you multiply 2 over x by xy, x goes away, you get 2y, and the rest of them follow. So if you look at this one, I want to show you one of them. If you multiply this one by this one, you get this one. Keep on going with the rest of them. This is what you get. Now the numerator, we can factor out the 2, and the bottom we can factor out in the form of a squared minus b squared, x plus y, x minus y. So the common factor of x plus y and y plus x. Notice this is y plus x, which is identical to x plus y. However, If it were y minus x, they won't be the same as x minus y, they would be opposite. So in this case, we are practically done in this. The next one, we multiply both sides by LCD. We are solving for Q. This is the fastest way to do that. So the LCD is simply all the denominators, P times Q times F. And when you multiply this by each fraction, for example, if you multiply this one by the first fraction, P goes away and you get Q times F, and the rest of them in the same manner. Since we are solving for Q, we want Q on the same side, therefore we need to move QF. That means we're going to subtract that. We factor the Q on the right side. We're almost done. We are solving for Q. All we have to do, divide by the parentheses P minus F, and this is the final answer. Remember, since you're solving for Q, your finished product can have only Q on one side, no more, no less. Solve. Fastest way to solve a rational equation, multiply both sides by LCD. It happened to be 4 for the first one. So what happens, the first fraction is 3x over 2. 4 cancels out the 2, 2 times 3x, which is 6x, and the second one, 4 cancels out, simply minus, and whatever is left, which is x minus 1, and the right side is just 1 times 4. So we rewrite the left side by distributing negative sign. We end up with 5x here. This is 5x. And then we are going to subtract 1 from 4. We get positive 3. So x is 3/5. The next one, in order to factor the next one, to solve the next one, we're going to factor the denominator for the next one, which is x squared minus 1. And it can be factored into x plus 1 times x minus 1. We're going to multiply both sides by LCD. So let's see what's the LCD here. This is part of the LCD. Also, we need 2. So 2 times the first denominator is our LCD. It is important when we solve a rational equation to pay attention to see what is an unacceptable answer. In other words, what makes the original equation undefined. So if we go back to this, you see x can't be 1, okay. If we go to this, x can't be 1, x can't be negative 1. So we mentioned that, and at the end, all we have to do, check with that. Okay. Now, when we multiply both sides by LCD, let's see what we get. We're going to multiply this one by the first one. So x squared minus 1 is the same as x minus 1, x plus 1, they go away. We are left with 2 and 2, which is the product 4. Minus 1/2, the 2 goes away, minus 1 times x minus 1, x plus 1, which we know it to be x squared minus 1. And the right side, x minus 1 goes away, but we are left with 1 times 2 times x plus 1. And all we have to do, finish the job here by distributing negative 1, getting 4 minus x squared plus 1, distributing 2, getting 2x plus 2. Now, we are going to bring everything to one side. Because we want a factor, we like the highest degree term to have a positive leading coefficient. So we're going to move everything to the right. By the way, 4 and 1 adds up to 5. So when we move it to right side, we are adding x squared and we are subtracting 5. I hope you see what happens. We are moving everything to the right. The result is x squared plus 2x, and then minus 5 is negative 3. Now we do a simple factoring. Therefore, there are two answers. One is x equals negative 3, one is x equals positive 1. We go back and check what we wrote here, and we know x can't be 1, x can't be negative 1. So this is fine. X cannot be 1, this is out. Jeff can mow grass in 5 hours. Mark can do it in 10. How long will it take him to do the job together? This is a class of problem known as work problem. So let us make up the following table. Jeff can do the job in 5. Mark can do the job in 10 hours. Always you need to know your units. You can put the units up here, here, here. As long as you remember, it's fine. Rate of work is defined as the speed, the amount of work done in 1 unit of time. So if you do the job in 5 hours, and Mark can do the job in 10 hours, we're going to discuss the rate. What about together? How long will it take him to do the job together? We have no idea. So that's why we use X. What is the rate or the speed by which they're working? That means in 1 hour, Jeff can do 1/5 of the job. Mark can do 1/10. They do it together in X amount, so 1/X. So first and foremost, together X. Secondly, this is the rate for each one. So in 1 hour, Jeff does 1/5 of the job. Mark does 1/10 of the job. So in 1 hour, we can add, this is the portion of a job done both, which is identical to this, as this is the same thing, the portion done by both. Needless to say, X can't be 0. We are looking at number of hours it's going to take him. Even if you didn't write it, it wouldn't be a big deal, but X can't be 0. Let's multiply both sides by LCD. I hope you recognize the LCD is 10X. So multiplied by the first one, you get 2X. The second one, you get X, and the right side, X goes away, becomes 10. 3X is 10. X is 10/3. Now, if you left it as that, it's fine. One of the reasons I like to see that in this format, because it clearly tells your reader that it takes a little bit more than 3 hours. And you can see, look at the time, if Jeff takes 5 and Mark takes 10, then working together must be less than 5. Okay, so it sort of makes sense by looking at it this way. This is precise. We are looking at a similar example. So at a dairy plant, a milk tank can be filled in 6 hours using inlet valve and emptied in 8 hours using outlet. Now we have both of them open and milk is being pumped into the tank. How long does it take for them to fill the tank? So we are going to practically repeat the same thing. So we have the inlet valve, outlet valve, time, rate of work. How long does it take them to work together? X. I hope you realize how easy work problem becomes if we continue with the same method. This is 1/6, 1/8, 1/X. Those are the rates. Now, generally speaking, in the case of a work problem, we work together and we have a plus sign. We help each other. In this case, since one of them is adding, one of them is emptying, is subtracting, so we have to subtract the one that is the outlet. So 1/8 is being subtracted from 1/6. Again, paying attention to the reading, that should help. Now, we multiply both sides by LCD again. which is 24x. Multiplication by the first one gives us 4x, the second one minus 3x, and the right side x goes away. Therefore, x is 24. The units are hours. I hope you realize why it makes sense, because one is filling up in 6, one is filling up, emptying in 8. So if they're working against each other, it takes a long time to fill it up. A train and car, right away, is a motion problem. And when you see a motion problem, immediately you should recognize D equals RT. D is the distance, R is the rate, T is that. R is the average of velocity. Train and car leave from Pasadena railroad station at the same time. The car averages 60 miles per hour, the train 80 miles per hour. The train gets there 2 hours ahead of the car, obviously, because it's going past it. We want to find the distance that they have covered. So let's set up a table. I can't emphasize the importance of a table again. So we have the vehicle, car, train, rate, time, distance. So let's put in what we have. So as far as the rate is concerned, the car is doing 60 miles per hour, train is doing 80 miles per hour. That's the first. Now, the timing is that if the train arrives at fair 2 hours ahead of the car. So let's say it takes train X amount to get there. So how long does it take the car? The same thing plus 2. Okay, remember, train is ahead. So it takes 2 hours less for the train and 2 hours more for the car. Now, distance is RT. So the product of these two is the distance. And the first one becomes 60 times X plus 2. The second one, 80 times X. We are going from point A to point B. We are covering the same distance. They must be identical. So practically we are done, because when we get to this, the rest is very simple algebraic techniques. 80x equals 60x plus 120. Subtract the 60x and divide, you get 6 hours. Now let's go back to the question. The question is asking find the distance. It's not asking for the time. Because of that, it's important for you to know your units. So you want to put time. So you want to put the hours here. You want to put the miles per hour here, and you want to put the miles. Therefore, when you answer it with proper units. Now, how do you find the distance? You have a choice. You can go here, replace the x with 6. By the way, when x is 6, x plus 2 is 8, okay? So 6 times 80 or 8 times 60. And that gives you 480 miles. I would check both of them. So replace the x with 6. This makes it 60 times 8. This makes it 80 times 6. The sum of the reciprocals of two consecutive integers is 15 over 56. We want to find the two numbers. When we say consecutive integers, that means if one is x, the other one is x plus 1. As an example, if you start with 7, the next one is 8. If you start with 10, the next one is 11. So 1, 2, 3, 4, 5. As far as the integers, I hope you remember that. The set of integers are as follows. Zero, 1, 2 to infinity. On the left side, -1, -2, all the way to negative infinity. Now the question is the sum of what? The reciprocal. So if one is x, the reciprocal is 1 over x. One is x minus x plus 1. Let me just fix that. This is x plus 1. So if one is x plus 1, the reciprocal is 1 over x plus 1, and the sum is 15 over 56. We are going to multiply both sides by LCD, which is 56 times x plus 1. We multiplied by the first one, x goes away. So 56 times x plus 1. Second one, x plus 1 goes away, 56. The right side, 56 goes away 15 times the rest of it, x times x plus 1. The rest is algebraic steps, because when we do applications, it's important to understand the concept. So we are going to distribute 15x, 56x plus 56 plus 56x, 15x squared plus 15x. We are going to combine these two, and we're going to subtract it from 15x on the other side. So we bring everything to the right. This 2 add up to what? 112x. We're going to take it to the other side, and we are going to subtract that. $56 moves. We're going to subtract that from the other side. We end up with the following. We do the factoring, or we can use the quadratic formula. There are two answers. So we have x minus 7 times 15x plus 8. Notice again the middle term, if you multiply these two, and if you multiply these two, this is minus 105x, this is 8x, they add up to negative 97x. So x is either 7 or negative 8 over 15. And why is it that we're going to drop this? Because this is not an integer. It is supposed to be an integer. The reason we drop it, it is not an integer class. We're going to go to the next topic, roots, radicals, and complex numbers. I want to remind you of a couple of things before we delve into the questions. So when you have this, this is the radical sign, this is the radicand, and this is the index. These are some rules we have seen. So quickly, those are exponential rules. A to the power of 0 is 1. A to the power of m times a to the power of n is a to the power of m plus n. This is the product rule. This is the power rule. This is a form of power rule, quotient rule. Okay. Again, power rule, negative exponential rule. So if you have a negative exponent, you take it down, you make it positive. If it's down, bring it up, or this one, you flip it over. These are some rules to refresh everyone's memory. The principal or positive square root, we show it with square root of x. The negative square root is minus square root of x. However, we don't want to mix it up with square root of 49. The moment you see square root of 49, the answer is 7. It is different than saying x squared is 49. What is the answer? It's either 7 or negative 7. But square root of 49 is always 7. When you take a root, the square root of a squared by definition is an absolute value of a, and everybody remembers absolute value is distance from 0. So odd root versus even root, the nth root of a or the nth square root of x, where n is an odd index and a is any real number, is called an odd root, and is the real number b such that b to the power of n is a. The even root, pretty much the same thing. Of course, we have a restriction. Okay, has to be a non-negative real number. In this case, b to the power of n becomes a. As far as their graph is concerned, and it's helpful to remember that, class. When you remember the graph, you remember just about everything about the function. So if you are looking at this function y equals square root of, you know that, for example, the x and y intercept happens at 0, 0. You know the domain is from 0 to infinity, and the range is also from 0 to infinity. So this comes from the graph. Remember the graph, it helps. On the other hand, for the cube root of x, there is looking like that. There is no restriction. Domain and range are all real numbers. So remembering the graph is helpful. Conclusion, the domain of a radical function are as follows. If we have an even index, values that keep it non-negative. In other words, if it's x is larger than or equal to 0. If it's an odd index, there is no restriction, and that's the difference between the odd and even. Now, in this case, we want to simplify the following. 24 square root of x, 4x squared y cubed. Let's put them all together. Now, we are assuming we are dealing with non-negative, otherwise we have to go with an absolute value. So 24 is out, it remains 4. Instead of cutting them into pieces, just think about them piece by piece. 4, we can take it as 2, x cubed, y cubed. Now, x cubed is the product of x squared and x. You have a choice. You can say 3 divided by the index, which is 2, 1, remainder 1. That means 1 out, 1 in. This is how it works, class. Again, this 4 comes out as 2, x cubed comes out as x, 1 remains, and y cubed happen to be absolutely the same thing. We are going to multiply this, resulting in 48x y and square root of x1. So that's the final answer. We are looking at part B. As I mentioned, there are many rules that we learned. We can flip this over and raise it to the power of positive. What does power of 1/2 means? Square root. And we know 16 gives us 4, 25 gives us 5. How about these two? Let's quickly handle those. A to the power of negative 2/3. I want to remind you of these rules that we have seen. A to the power of m over n. N is the index, m is the exponent. Whether you put it in or out makes no difference. However, when you put it out, it makes it easier to do the math most of the time. If it's negative, it goes down and you do the same thing. So first, you can take it down and then change it according to this. Okay. Now, what is cube root of 8? 2. Let me just write that. So this changes to 2, square it, and you get 4, 1 over 4. This one, there's really not much you have to do. 81 comes out. You can take this, the square root of the numerator, which is 9, square root of the denominator, which is 13. To make some more sense out of this, I gave you this question. Here's the easy way that I'm going to handle it. I want you to pay attention to that. $64 is 2 to the power of 6. Look at the index. So we are going to divide all the exponents by the index. So if I divide 6 by 5, I get 1 with the remainder 1. Yes. So that means 2 out, 2 to the power of 1 out, 2 to the power of 1 in. The next one is 10. Divided by 5, I get 2. So it's x squared. There is a 0 remainder. There is nothing inside. Use a different color. 23. I'm going to divide it by the index 5. Gives me 4. With the remainder 3. That means y to the power of 4 is out. Y cubed is in. This is the final answer, and this is the fastest way to handle a question like this. All right, we want to simplify. We start with the first one. We put them together. So why don't we multiply these two? We get 20xy cubed z. The denominator doesn't change. We got to cancel everything and we end up with square root of y squared. Now, if we don't know anything about y, the answer is absolute value of y. If we know it represents a positive value, the answer is y. So it depends on how we receive the question. All right, there are a couple of different ways to handle part B. The first one would be to simplify the fraction first. Ignore the 2/3, keep it, start simplifying. So 54 and 2, they cancel each other, they give us 27. So you can do that. Okay, 54 and 2. Now, a to the power of negative 3/4, a to the power of negative 2. You have a choice. You can take the negative 2 up and make it a squared, and then combine them. You can do them in one shot. B to the power of 5 and b squared, they cancel each other, they give us b cubed. So notice this I didn't do it in one shot. I just want to show you that we're going to do it in 2 shots. So in other words, negative 2, I'll take it up. Now we are going to combine by adding negative 3/4 and 2. Or we can raise it to the power of 2/3. Let's do the math. This is a to the power of negative 3/4 and 2 is 8/4. They add up to 5/4. So let me erase this part so it makes it easy to see how we added negative 3/4 plus 2. 2 is 8/4. Now we are going to everything to the power of 2/3. We're going to raise 27 to the power of 2/3, this one to the power of 2/3, and b cubed to the power of 2/3. So 27 to the power of 2/3. We're going to multiply this one by 2/3, 10 over 12, and b cubed by 2/3, which is b squared. Now look at them one by one. This means cube root of 27 squared, which means squared, which means 9. A to the power of 10 over 10 means 5/6. Simple. Erase this part. Okay. The last one, basically 20 divided by 4 gives us 5. Again, we don't know anything about the variables. We put them in absolute value. If we do, they are coming out. Simplify. If they said simplify or rationalize or D means the same. So the methodology is to multiply by the conjugate of the denominator, which is square root of 2 plus 3. If we are multiplying that, we have to multiply the top by the same thing because this fraction now is justifiable. It's equal to 1. Otherwise, you can't do that. So now let's multiply. So this one gets squared up because identical. This comes out as 2. Then 2 times the first times the last. That means 2 times root of 6, and then this one comes out as 3. These two, you use a minus b, a plus b, both come out a minus b, 2 minus 3. So the numerator up to 5 minus 2 square root of 6. Five plus 2 square root of 6 is negative 1. So the numerator is 5 plus 2 square root of 6. The denominator is negative 1. So everything changes sign. With part B, we multiply by the conjugate of the denominator, the top and the bottom as well. The top, you just write it as times the top, and the bottom comes out as 6 minus x. 6 squared minus x, which is 36 minus x. Whether you want to put the top in the form of a 12 minus 2 squared of x or 2 times 6 minus square root of x, it's up to you. On a normal basis, I would keep it as a product simply because maybe these two we can cancel out with something, but either way is fine. All right, we want to see how we take care of the business here. In order to rationalize, we don't have any radicals here. So we look at the index. The index is 3. If we can make the exponent equal, we are in good shape. So when we look at the 5, we have to multiply it by 5 squared in order to get to cube. This one we just multiplied by. We do the same thing for the numerator. So one more time. For 5, we need 5 squared. But for y squared, we just need y. If you multiply, look at the bottom only. If you multiply them, you get 5 cubed. Okay, I'm going to write that. You are going to get 5 cubed y cubed under the radical, and it comes out as 5y. You don't have to, write down the cube with a 5 cubed y cube, but I'm showing you this is one way to deal with that. And that's basically it. The numerator, you just write it just the way it is. However, when you look at part D, we don't have an index. The index is 2, obviously. So in order to rationalize, you want to take the 5 out. All you need to do, multiply by another 5 under the radical. And you do the same thing for the top and the bottom. Remember, this fraction equals 1. 1, 1, 1. Otherwise, you can't just do that. You have to multiply the top and the bottom by the same thing. So having said that, this comes out as 5, and this is 5 square root of 15. So the 5 cancel out. We end up with square root of 15 only. Solve and check. Even if they don't ask us to check, that is normally the methodology. You got to check your final answer. Whenever you're solving a radical equation, your very first step is to isolate the radical. Therefore, in this case, we have to move number 7. Now that it's completely isolated, how do we get it out? We have to raise it to an appropriate power. In this case, raise it to the second power. So let's raise both sides to the second power. This comes up. The right side, remember, it's a minus b quantity squared, which is a minus 2ab plus b squared. Remember that. So x squared minus 14x plus 49. Some students miss that. Be careful. I'm going to bring thing to the right side. This 2x becomes minus 2x. This plus 1 becomes a minus 1. Now we do the factoring. X minus 4 gives us x equals 4. X minus 12 gives us x equals 12. So there are 2 answers. We must check. Checking takes place with the original equation. So you're going to put 4 work it out, 12 work it out. So let's go one by one. Let's check 4. If I put 4 here, I get the square root of 2 times 4 plus 1 plus 7. Is it equal to 4? That's what we are checking. So 2 and 4, 2 times 4, 8 plus 1, 9 comes out as 3 plus 7, which is 10. Is it equal to 4? That's why I put the question mark on both sides of the equality. No, they are not equal. So that's out. What about 12? Let's check it out. 2 times 12, 24, plus 1, 25, comes out as 5 plus 7 is 12. Are they equal? Yes. So number 12 checks out. We want to simplify the following. So the first thing I want to remind you is the following. I equals square root of -1. I squared is -1. If you cube that class, multiply these two, you get -1 times I. Do you see that? And then I to the power of 4, square this one, square this number, you get 1. If you have square root of -1 is I, as was mentioned, square root of -n, here's how you write it. And if you multiply these two, you get a squared plus b squared, because it's a squared minus, the reason why I want to remind you is because when you multiply these two, you get a squared minus b squared I squared, and that's why it's a squared plus b squared. So having said that, how do we simplify something like I to the power of 1225? Because we know that this is true, all you have to do is divide 1225 by 4. Because anything to the power of 4 is 1. This is the fastest and easiest way. This is not the only way, but this is the fastest way. And all you have to do, keep the remainder. When you divide 1225 by 4, I hope you realize 1224 is divisible because 24 is divisible. Therefore, the remainder is 1. So I to the power of 1 becomes I. Part B, flip it over, make it to the power of 6. Now let's do the same thing here. If you divide number 6 by 4, the remainder is 2. So 1 over I squared. And we know I squared is -1. 1 over -1 is -1. Here's another example. 37 divided by 4 is 1. So I to the power of 1. Let's make it I to the power of 39, class. 39 divided by 4. Remember, we just want the remainder. It is 6 with the remainder 3. So this is I cubed. And you're not finished. And after that, you have to write down equals -I, -I. Here's the next one. We are going to simplify or divide or put it in standard form of a plus bi. They all mean the same thing. We multiply by the complex conjugate of the denominator, which is 3 minus 2i. So we're going to multiply and divide by it because this is equal to 1. So the bottom is easy. Remember, I've shown you this is a squared plus b squared. So this is 3 squared plus 2 squared. And this one you just distribute 5 times 3, 15, minus 10i, minus 6i, plus 4i squared. So we are just imagine I is x, do the math. Later on, figure out what I squared and the rest of them are. Okay, so these are easy. 3 squared, 9 and 4. This is 13, so we know that. Now 4i squared is negative 4. So we can add 15 and negative 4. We can add negative 10i and negative 6i. This is what we get. If you left it as that, it's not a big deal. However, it's a good practice to write it in this format because now your reader knows precisely what your A is. What your B is. A is 11 over 13 and B is negative 16 over 13 because we are writing it in the form of A plus BI. We are going to multiply these two. 3 plus square root of negative 4 times 1 plus square root of negative 1. The very first thing, we go with this process that was mentioned here. We change this to 2i and we change this to I. And now we distribute. So we get 3 plus 3i plus 2i plus 2i squared. And again, 2i squared is minus 2. With positive 3, they give us positive 1 plus 5i.